I wasn't able to make a dedicated PPT, so I'd like to present my proposal form. And I'd just like to start a bit on where my thinking started. So, we are basically talking about adding a conversation space to enhance the simulation that some communities use Slack to talk. So, the talking in Slack is obviously bound to change the GitHub PRs and issues, etc. So I've been thinking of reworking the motivation system we have in the project. So the current motivation here I'll show. The current motivation is a bit like this. If someone's PRs get accepted, then his or her motivation rises. If they get rejected, then it falls down. So this is a very good starting point, but I believe it will become more complex and it will need to be updated whenever we add the conversation space. So I have looked through some research papers on motivation, and in open source communities, motivation is the primary predictor of contributor productivity and retention. So motivation is basically the central thing for this project. And one more research uh, quantified the prediction of individual motivators. And here it divides basically into two types of motivations. First is intrinsic motivation. We've also studied it as internal motivation and external motivation such as money or community. So this is the table from this paper, and as we can see, the internal motivators, enjoyment, ownership, learning, things which are limited to oneself internally, they are much more better at predicting the motivation, and these should be focused in an open source to help increase its sustainability. And external motivators are rated a bit below at prediction of a motivator. So now this one was a bit surprising to me as well. Payment doesn't cause as much motivation as enjoyment or ownership, most likely due to burnouts or some other things. So firstly, I would like to rework this motivation system, and I'll use these as weights to update a motivation whenever when an action takes place. Now, second is I want to talk about the agent actions. Now, actions of an agent right now, they are just submitting PRs and reviewing the code. So I'd like to expand the action set of one agent so they can join a project, they can talk in conversation space, they can comment on a GitHub issue or a PR for a better structured discussion. They can submit the PR. Now this is currently implemented. I don't think this would need much more work. The core members can assign issues, reviewing code whenever available, opening a GitHub issue. Right now, everything starts at the beginning, and the contributors don't open the issue. It is basically opened by the system. So I'd like to implement the capability for an agent to open the issue as well. Leaving the project, I'll talk about the leaving and joining part later, and mentioning another contributor. Now I think this is very central part to emulating a real discussion. We use @signs to mention other contributors, such as someone has started talking, so we would mention them and continue the conversation that way. So these are the actions one agent can have. I'll refer to them as actions from now on. Now, this is my favorite part. I think Vidhi also touched on this on her presentation. Roles in an OSS project. So, I've gone through this paper by Chang and Guo, and they have analyzed 20,000 more than 20,000 unique contributors in 29 GitHub projects. Now, I'd like to make this diagram a bit bigger. So, uh, this is basically them clustering the overall contributors into two major groups. So there's basically two groups: supporting participants, which are the silent majority. They provide much less value to the project compared to the active participants, which are the minority, but they do most of the work. So I think in the current implementation of the project, uh, we can use analogy that supporting participants are the contributors and active participants are the maintainers. So this is the first thing. And now these are the major groups. These groups are divided into minor groups as well. Uh, yeah. So here are the minor groups which are the active contributors can be divided into. Now these are based on the actions they take. So intense code contributors, coordinators, code developers, and all-rounders. These are the four major groups, and they all perform different actions. So here are the actions they perform. So all-rounders are the middle part. They perform everything at an around equal level respect to each other. Coordinators, they focus on issue reporting and knowledge sharing and issue coordination. Code developers focus on progress control the most, and they don't report issue as much. Now this is my favorite group, intense code contributors. They are the ones focused on code contribution. As you can see, the part actually goes out of the diagram. So they are very focused on the code contribution part. So we can model the maintainers based on these roles. We can assign them one role and then model it. For example, if we assign one maintainer agent to be code developer, then he would not report many issues, but he will focus on progress control and knowledge sharing. So this way we can actually test how the open source project will develop under one type of maintainer. And similarly, the contributors can also be assigned into 6 different roles. Now, I think only one group stands out here the most. Those are the rare contributors. These are the majority, and they provide the least value. As we can see, they have almost everywhere they have the lowest distance from the center. And we have some specialized supporting contributors. Some engage in issues, some engage in fixing those issues, and there are progress based also. So we can basically model these roles into our project, so we can test how better how which leadership is best for an open source sustain to be sustainable, and what type of contributors supporters are best. Now one more thing I'd like to say here is the changes in role. Now we know that one person who is core developer will get burnt out and he may move to a smaller role, or there's someone who is highly motivated and highly skilled, so he can move into a upper role to be a maintainer of the project. So we can use this graph to model a Markov state type of diagram, that if someone is a rare contributor, that means he rarely contributes, then he is most likely to leave the project, that is being absent. Now, I'd like to point out the rare contributors. These are the these are the most, they like, if someone is absent, then he is most likely to become a rare contributor. And if someone is a rare contributor here, then he is most likely to be absent. So this shows that the current simulation basically keeps them in a box. So I'd like to model also this to be more dynamic. We would like to give one agent the freedom to leave or to join a project. So I have talked about this later. Now I am skimming this through a bit, but here's the diagram I have made. The current model is like this. We are essentially keeping them in a box. They can't leave or they can't join. So I'd like to propose an active classroom type of approach. We have the watchers who are looking at the project but they are not contributing and they are outside the room. On the doorway, there are rare contributors, those who contribute the least. They have the tendency to leave and they have the tendency to join the more active roles. Supporters can become the all four roles can transmit to trans can convert to another role based on this diagram I have shown here. So about the initial state, I had this idea for this graph that under we are able to program what type of contributors currently they are acting as. So we can test like what happens under an all-rounder leadership, what happens under an intense contributor. So I was thinking that initial state would be choosable by us users. So regarding the roles part, I think this just represents the average. So uh, in the project, we would obviously have to introduce some variance and standard deviation. So it actually mimics a real person. So I think that will need to be tested multiple times and we'll eventually get to a realistic value. And yeah, we would need to introduce some variance. Each contributor has a different graph, but it is closer to one of the six standard graphs. So I think that is one way we can mimic the real world. Okay, moving onwards. So the current LAMSOC capabilities and limitations. So the motivation update algorithm, I've talked about this briefly, but it is, I believe it is based on three signals: bit selection, PR merge success, and code quality score. These are what uh, influence the current motivation in the project. So I think this is a bit simplistic approach. We can obviously make it better to have a bit more realistic, such as ideology, money incentive, etc. No conversation space emulation. I think this has been touched on before this presentation that this can't mimic a real open source development environment. So we have to introduce one. GitHub discussion structure. Now the current project has this one panel, and most of the discussion occurs here. So that we are basically jumbling everything in one place. So I was thinking updating the front end a bit like the current GitHub we have. We have pull requests and we have discussions going on to in different pull requests like this. So that can be used instead of this. So that won't require much work. I think we would just need to tinker a bit with the front end and have the agents talk into the separate things. No personality configuration. Right now, the personality of an agent is written statically. So it is basically just one string which we can modify to change the agent's behavior. So we can just add a bit to the front end, which allows the user to use some pre-built or a custom personality that we can use. No role-based simulation of actions. Right now, they work on bidding for the contribution part. They are chosen based on motivation skill level. So I think we can add a bit of autonomy there. And for the conversation part, I think they just talk in a for loop. So that's not how a real conversation works. We have to give them individual autonomy, what they want to do based on their personality and their whatever role we give them. And I've talked about this before, the current model and my proposed newer model. And here are some of the references I found to similar projects. Now, I think this project has a very good starting point. Now, I couldn't find any research paper for emulating a Slack-like behavior, but I am able to find some GitHub projects. So I was thinking some implementing something like this, wherever there's an event, then there's some randomness, and basically we use this architecture to emulate the current whatever message we want our agent to send, whatever conversation we want them to have. So for seed, this decides how the conversation will go. So to emulate different channels, we can have a different prompt. For example, we have, I think in Slack we have a random channel. So there we talk about random things. I think someone made a Valentine's Day project, so that was pretty fun to go through. So we can have different channels based on this seed variable. We can have one string describing only serious talks, one string describing only informal talks, such as that. So through that, we can all use these references to have a better understanding for what we want to implement. So now proposed implementation I have for conversation space is this. The agent, the agent will, uh, uh, I think I should go about one more thing here. That is turn order. Turn order. In one time step, we can only have limited actions, and this will be decided through an agent through this mathematical formula. I have found this through an paper. Now I am working on this part, so I'll talk about this later. But whenever an agent's turn comes up, we will have basically two different LLM calls. One will decide what action it wants to take. Does it want to open an issue? Does it want to make a comment? Does it want to talk informally to the Slack channel? Then we have RAG part. Now, this RAG part will retrieve the context and then we will execute our action. So, the division of labor to two different AI calls will allow us to have a better result here. We don't dump all the decision burden onto one. This will allow us to have a better uh, this allows us to have a better performance and emulation. Now about the RAG part, I'm thinking that the current messages and the long-term messages which are relevant will be emulated here. There will be a Slack message memory. This will have all of the informal messages, all of the channels, all the threads that was recently talked into. The GitHub comments, if the agent wants to go into the GitHub part, make a new issue, start a new PR. We can have a PR or issue if it want to review some previous issue or PR that has been published. And then the main part here is motivation events. We will decide how the motivation will be affected through some mathematical formula, or we can also ask some pre-trained sentiment analysis models, and this will make up the RAG retriever part. So after getting all this information, then the action will be executed, and then it will go onward to the next agent, and the process will continue. And one final thing, now I'm thinking the presentation is getting a bit longer, so I like to end it right here. Now this is my favorite part of the project, GitHub profile scraper and personality configuration. So we have talked that GitHub users tend to have very vast different personalities. So to emulate that, why not we use the current GitHub profiles we have over the internet? So this will obviously be anonymized. We don't want it to get misused. So all the GitHub users will be hashed in the storage, and scraping will be rate limited, like one user data per minute or something like that, so that it won't be misused. So now the here's my web scraper architecture I'm thinking of. We have the web scraper algorithm. It will get the data in a JSON format, and it will sanitize it through various means. It will hash it so it's not traceable, and we'll use an LLM to generate a personality text. This personality will help us emulate that person's behavior, into our agent contributor. So these are the three main things that the web scraper will tend to analyze. First is the way of talking, how uh, how politely that person talks, and then we have action taken on an average. So this will help us identify maintainers and contributors. We can model it through that. And finally, the role part I talked about, we can predict it through commit, issue, and review and PR split. A person who is opening more issues is obviously focused on issues, so he is one of these engaged issue reporter or an occasional issue reporter. So through getting these data, I think I've seen this multiple times in a GitHub profile readme that there is one graph similar to uh, similar to this one, which shows this hexagonal diagram, which shows how much this person is contributing as related to how much this person is opening issues. So through that we can map out one of the personality, and then we can obviously add some variance to emulate the real part. So that will do for my presentation. Now, any feedback on the next part I've talked about?
Yeah, so I think this part is. Can you go back to that equation you showed? I wanted to see something real quick.
Yeah,
Yeah, that one. So that's the turn order formula. So that's a softmax
yes.
function that's kind of like with burst. It's
Yeah,
additive
it's
with
predicting.
burstiness.
Yes.
Okay,
So,
could you go through that a little
so
bit?
yeah. So I haven't actually worked on this. I ran out of time, but I like to give the gist of it. So we have the probability of an agent uh, taking an action, and this probability will be calculated on, first of all, basis of the motivation. So the motivation is again a central part to this project. Then we'll talk about the action weights we will use. So that is will be based on the rules. Now we will have to add some variance again to make that more uh, make it more realistic. Then there's burst. So we tend to see that the agent will do multiple functions at once. We see that in a conversation, there's multiple times, multiple messages to convey one overall message. Use so this burst will try to emulate how much, how frequently there will be chunks to messages and actions, and the network part will use the page rank. Now this page rank wasn't clear to me, so it's in these docs. I'm working on this. I'll talk it about a bit later. I think I've ran out of time. I was reading through so many papers.
Yeah.
So
I think the page rank
this is,
algorithm is used as kind of like a way to go through like
yes,
order, like rank your members of your network and then go through the order. I mean, they
yes,
use it for very
yeah,
large networks when they're doing search engine
yes,
work, but you can use it on smaller networks, as far as I know. Like,
yeah. So we can divide one time step into multiple contributor actions. So we can use this to predict which agent is most likely to perform, and we can obviously add some randomness to it to add more realness. And what any thoughts about this part, web scraper to get the personality?